All right, I just wanted to review simplifying radicals and start with square roots because that's what we know. We've been doing that for months, and then show you the same method and whenever you have to simplify cube roots and fourth roots and on, okay? Typically it's going to stop with fourth because numbers get pretty large after that. So whenever we simplify a square root, you guys know that we sit back and we think of our factor pairs. Well, the only factor pairs that matter are our perfect square pairs. So just ask yourself, okay, our perfect squares are 4, and 9 is the next perfect square, 16, and 25, okay? Only worry about the perfect squares. Don't worry about all of the other pairs because they won't actually simplify. They won't do anything for us. So does 4 go into 75 evenly? No, it doesn't. 9 does not go in, so that one's out. 16 does not go in. So 25 is our first factor pair, or is our first perfect square that is a factor pair. It's 25 times 3. In this case, that's all the factor pairs are, 25 and 3. So after that, we say, okay, well that means that this is 25 times 3, and we know that after that, we actually square root the 25, and we get 5 root 3. Okay? And you guys know that. We've done that for a while now. All right, but I wanted to remind you that you use your perfect squares until you get a factor pair that works. So the same idea for 54. You could go through a bunch of different pairs, but you only care about perfect squares. So 4, 9 is the next one, 16 is the next one, and 25. Okay, if none of those work, or if 2 of them work, chances are it's going to also be one after that. All right, hold on one second. All right, just wanted to grab my calculator. All right, so, but 4 does not go into 54. It goes into 52. So we know that that one doesn't work. Okay, 9 into 54, that would be 9 and 6. 16 doesn't go in because 6 is divisible by 3 and 2, and 16 is not. Okay, and 25 doesn't go in. So it looks like this is the only pair that works. So again, we know that that means that is the square root of 9 and 6. So that will square root out to 3 root 6. All right, so we've dealt with our number just like we always have. And then the only thing I added was that we have to simplify the x's. So remember, we can write that as fractions. Excuse me, that should be to the 4 over 2. And this one should be to the 3 over 2. And so this actually reduces. 4 over 2 is x squared. That actually comes out perfectly. So this is how I normally like to set things up. I normally like to just have the radical, and then I put things outside and I put things inside. So we've already decided that the 3 should go outside and the 6 should go inside. Now when it comes to our x squared, because that will reduce, that completely comes outside because that reduces perfectly. And then this, if you think about it, 3 over 2 is just 1.5. So this 1, this big 1, tells us that one of these will come out. So this big 1 represents the 1 right there. And then the 1 here, let me see what color I can use. All right, the 1 here tells us that I should have 1 left inside, okay? So whenever you have to do your fractions, make it a mixed number. The whole number is how many you can pull out. The remainder, or the numerator, is how many have to stay in. So that's how that would reduce. We do our square root, and then we deal with our powers separately. Some come out all the way, and some stay in. Typically, we do not write those ones. So here's our final answer for a problem like this. All right, so what I want us to do is I actually want us to use the same methods for doing cube roots. But instead of looking at perfect squares to find the factor pair that we want, we're actually going to look at cubes instead. So the first cube that we have, 2 cubed, is 8. Okay, and we've been practicing that. We've been looking at those a lot. The next cube that we have, 3 cubed, is 27. And then the next cubed after that is 64. Okay, because this is 2 cubed, 3 cubed, 4 cubed. Chances are it's not, well, this one definitely isn't going to go higher because it's only 32. So when we ask ourselves, okay, this is 8 times 4, that works. 27 does not go into it, 64 does not go into it. So it must be 8 and 4. So just like we did with square root, we say, okay, well that's the cube root of 8 times 4, because that one's a perfect cube and that one is not, but that's the pair. So then we actually can cube root the 8, that's a 2, cube root of 4. Alright, so we cube out the number that we can, we leave the number that we cannot. So again, it's the same method, but we're just doing it with cubes instead. So the same idea here, we go off to the side and we say, okay, our cubes are 8, 27, and 32. Not going to be higher than that because 32 doesn't even go into 54. Alright, 8 does not go into 54. That would be 56. So that means it's 27 times 2. So we go off to the side and we say, okay, well when it comes to our roots, that means it's 27 times 2, and that's a cube root. We're going to evaluate that in a second. Then we also look at our powers, so that's n to the 3 over 3, 3 over 3, n to the 7 over 3. Now let's write these either inside the radical or outside the radical. So I just kind of put a radical generically in the middle. We're going to have some stuff in front and some stuff inside. So the first thing we're going to do, the cube root of 27, that's why we chose it, is a 3. That means that the 2 is still left. So the radical separates like that. Now, 3 divided by 3, that's just 1. This whole thing comes out, m to the 1, because that reduces down to 1, but you don't really need it. Okay, and then to do this part, again, just think to yourself, okay, well, 7 thirds, 3 goes into 7 2 times, that's the whole number, so that's how many we pull out, so that's n squared, and then the remainder would be 1/3. And remember, this remainder right here is how many you have left in. Let me use this one instead. Okay, so that's how many you have left in. So you have an n to the first left. So the 2 relates to the whole number. This squared comes from the whole. How many in whole can you bring out? And then the 1 relates to the remainder. But you typically won't see it. So that would be our final overall answer. Okay? Alright, so then this last one, again, 162, that's a huge number, but since it's 4th root, you just have to think of 4th roots. So I don't think I have enough room to go to the side, so I'll go to the side over here. So the first 4th root we have is 2 to the 4th. So that's 16. Okay, and then it jumps pretty quickly. 3 to the 4th is 81. Okay, and then 4 to the 4th, I believe, is 256. 4 to the 4th, yeah, is 256. So these are our first 4th roots. 256 is already too big, because that won't go into it. So then, 162 does not divide by 16. 162 divided by 16. Nope, it does not. So that means this is our only pair. So it's 81 and the number 2. Okay, so here's our factor pair of that. So we would say the 4th root of 81 and 2. That 81 is going to 4th root in a second. Now I'm a little bit running out of room, so let me write the variables below it. So that's q to the 6 over 4 and r to the 8 over 4. And then we just put all of our pieces either inside the radical or outside. So here's our radical. It's a 4th root. Let me go ahead and erase this just so that it doesn't get confused in there. So let's pardon me, 4th root, the 81, that's 3 to the 4th. So that means a 3 is going to come out, a 2 is going to stay in. Now let's look at our cubes. How many times does, or if you go off to the side, 6 to the 4th is 1 and 2/4. All right, because it goes in one time and there's 2 left over. So you can pull 1 of your cues out and you have 2 of them left. So the 1 is what you pull out, the 2 is how many you have remaining. And then the nice thing about 8 divided by 4, that reduces. That's just a 2. So that just means you pull 2 of them out. And you don't have anything in because it reduces, there's no remaining, so the r squared comes out. So that is how, that's how this one would reduce. And instead, we just have to think of 4th roots instead of square roots or instead of cube roots, all right? And then we still do the same exponent rule to say how many come out and then how many are remaining.